Welcome back, everybody. We're going to be starting the final unit of our school year, which is going to be polynomials. Now we're going to talk about what polynomials are. We're also going to talk about what operations we can do with polynomials. For now, we're just going to focus on what polynomials are, how to add and subtract polynomials, and how to multiply polynomials. The final part of this unit is what's known as factoring, and that's the idea of how to divide polynomials, or how to find out what factors we can pull out that we could divide by evenly. So why don't we get started? The first thing we're going to talk about is what a polynomial is, and then how we would classify a polynomial. So a polynomial is any expression we can write, and the name polynomial insists that it would have multiple terms, but we can have a single term expression, which we refer to as a monomial. It's all about the prefix in front. So polynomials is sort of a word that we use to encompass all types of expressions and how we would be able to classify them. And then what we're going to do is we're going to talk about them a little more specifically. So if we understand the idea that a polynomial is an expression with multiple terms, and when I say term, I mean any value that you can multiply or divide together would be one term. If you have to add or subtract to it, that's another term that would have multiple terms. So for instance, if we're classifying polynomials, if I was to write something like this, 2x squared. X squared means x is multiplying by itself. 2 means that the 2's multiplying are x squared. That entire thing is one term. If I were to add on to it, plus 3x, that would be another term. And if I subtracted from it, or added to it again, that would be 3 terms. So just to give you an example, this right here we would call a polynomial in general, but more specifically we can name it another way. So depending on the number of terms a polynomial has, and the degree of the largest term, and when I say degree I mean how big is that exponent going to be of the largest term, we can actually give 2 specific names to each polynomial. So for instance, this polynomial up here, if we wanted to be more specific, it has 1, 2, 3 terms, so that would make it a trinomial. And we also want to look at the largest degree, which in this case is a 2, so that means this would be quadratic. So this would be a quadratic trinomial. So when we talk about classifying polynomials, what we're really doing is coming up with a name for it to describe exactly what kind of polynomial we're dealing with. So the way we would classify based on the number of terms, if we had a one-term polynomial, it's what's referred to as a monomial. So if you ever see mono as a prefix, it means 1. So for instance, those of you in world studies right now, if you've heard about a monotheistic versus a polytheistic society, what they're talking about are the number of gods that that society believes in. So monotheistic would mean 1, polytheistic, like the ancient Greeks or the ancient Romans, would have multiple gods. So mono meaning 1, poly meaning multiple. So in this case, monomial would mean 1 term, and that's the mono part that's letting us know the 1. The next classification we could use would be binomial, which would mean 2 terms. Right? So if you see bi as a prefix, it means 2. Like a bicycle has 2 wheels. Building off of that, if we had 3 terms, we'd call it a trinomial. Again, look at the prefix, tri, in this case 3. So we would have 3 terms, and that's how we would be able to tell. So monomial 1 term, binomial is 2 terms, trinomial is 3 terms. If you have anything larger than that, instead of going into the details of what we could potentially call it specifically, we're just going to call it a polynomial. And we would say how many terms it would have. So a polynomial with 4 terms, or a polynomial with 5 terms, and so on. And so anything 4 or larger, we would call a polynomial. Now as far as degree, what we're going to do is we're going to look at all the terms, we're going to find the one that has the largest exponent, and we're going to count, or we're going to look at what that number is. If we had multiple variables, we would count how many we would have all together. But in this case, all we're going to do is we're just going to look which one has the largest exponent. Well, in this case, it's x squared, so it would be 2, so it would be quadratic. But the degree of the largest term is going to also be a way we would classify a polynomial. So if the largest term we had, for instance, let's say I just gave you this, -5. Well, it's negative 5 times x to the 0 power, because there's no x there. X to the 0 equals 1, if you remember. So anything to the 0 power, because we don't have a variable in there, we're going to call a constant. Okay, so this is an example of a constant. It's always negative 5. It doesn't matter what x changes to, because there's no x in this expression. If we had something that was written more like this, 2x. Okay, so we could have 2x as a monomial, or we could have 2x plus 3. Whatever we have, 2x, all right? This is x to the first power. So our largest degree is 1, which would mean it's linear. Okay? If we had this expression, but it was 2x squared, we would look, okay, second degree, that means it's quadratic. And so that's how we would classify it as far as the largest term. And then we go on forward from there. So if we had 2x to the third plus 3x squared, let's say, again, we'd look at the largest term. In this case, it's 2x to the third, okay, because that exponent is larger. And we would just take a look, what's 3? 3 is cubic. And we keep going from there. So if we have a degree of 0, it's constant. If we have a degree of 1, it's linear. Degree of 2 is quadratic. Degree of 3 is cubic. Degree of 4 is quartic. Degree of 5 is quintic. Degree of 6 or larger, we'll just say is an nth degree polynomial. So for instance, if this was 2x to the 10th, for instance, and that was the largest exponent in the expression. And it doesn't matter if it's first or not. For instance, if I gave you 6x to the 5th plus 2x to the 10th, we would focus on this one because that's the largest exponent. We'd look at it, it's to the 10th degree, so that would mean it's going to be a 10th degree polynomial. That's how we would name it. Now every polynomial we have is going to get two names. One based on the number of terms, the other based on the degree of the largest term. So if I were to write out something like this, 2x squared plus 6x to the 4th minus 3x plus 5. What we would have here, first off, this would be a polynomial with 4 terms, because there's 1, 2, 3, 4 terms. And it would also, if we take a look, the largest exponent we have is 4. So what we would do is we would say this is a quartic polynomial with 4 terms. And that's how we would say it. If we change this around a little bit, maybe I'll change this to a 5. And let's say we just drop the 3x from it and we do something like this. So 2x to the 5th plus 6x to the 4th plus 10. This would be, it's got 3 terms, so it's going to be a trinomial. And 5 is our largest degree of any term, so it's going to be a quintic trinomial. So that's all we have to do. You just take a look at both lists, figure out which one it qualifies for both lists, and pick a name from each list. And that's all you have to do. So for instance, I'll put one more up here. If we had 2x to the third. 2x to the third, it only has 1 term, so it's a monomial. And it's to the 3rd power, that's the largest term we have, so it's going to be cubic. So we need to have a cubic polynomial, and that's how we would say it. So that's all you have to do as far as naming. Now, as far as naming, there's one other thing we should talk about, which is the idea of standard form. You'll notice before I gave you a problem that looked like this, 2x squared plus 5x to the 4th plus 3, let's say. Whenever you're asked to write an expression in standard form, what we're looking for you to do is to organize based on the degree, from largest degree to smallest. So you'll notice we have 3 terms here. You want to include the sign in front for each of those terms. We need to organize them largest degree to smallest degree. You'll notice here our largest degree is the 4th power, so we would start with a positive 5x to the 4th power. We would then have a positive 2x squared next, so we would add 2x squared, followed by a positive 3. And that's how we would write this expression in standard form. So if you hear the term standard form, that's what you need to keep in mind. But again, as we're naming these polynomials, you could have written it this way or that way. It won't matter. it's going to be the same thing no matter what order the terms are in, because it'll still have the same number of terms and it'll still have the same degree. In this case, this would be the degree of the largest term is going to be a 4, so it will be quartic, and there's 3 terms, so it's a quartic trinomial. So as far as naming polynomials, that's all you really need to keep in mind. All right, so that's the first part. Now what we're going to do is we're going to talk about adding, subtracting, and multiplying polynomials. And we'll get to dividing when we start talking about factoring. But as far as adding, subtracting, and multiplying polynomials, the process seems hard, it's really not. For adding and subtracting polynomials, it's as simple as combining like terms. For multiplying polynomials, which we'll get to in a minute, it's as simple as the distributive property, which we'll practice a little bit first before we get going on it. So for adding polynomials, what you want to do is you just want to combine like terms with any terms that have the same degree. So what we'll do here is we'll take a look. So the largest degree I have is to the 3rd power. So I'm going to start by adding any values to the 3rd power that I have. I have 6x to the 3rd plus 2x to the 3rd. That would give me 8x to the 3rd. All I'm doing is combining like terms, where the terms are whatever the exponent is. We only want to combine exponents that are the same. So if we have an x squared and an x squared, we can combine them together. If we have an x squared and x to the 3rd, we can't. We have to leave them next to each other, still being added or subtracted. So we have our x to the 3rds, we add them together, we get 8x to the 3rd. We do the same thing with our x squareds. We have a 4x squared, a positive 4x squared, a negative 10x squared. All you have to do is add the coefficients, the numbers in front. So 4 plus negative 10, 4 plus negative 10 is like 4 minus 10, which would be a negative 6. It would be a negative 6x squared, because we were adding and subtracting x squareds. Next, we want to look at x to the 1st power. We have a negative 7x. We have a positive 8x. When you combine them together, we get a positive 1x, or just a positive x. And then our final one, we're going to add our constants. We have a positive 3 and a positive 10. That's going to combine for a positive 13. So when I add these two polynomials, what I'm going to get is 8x to the 3rd minus 6x squared plus x plus 13. And that's all there is to it. We're just combining like terms. Typically, when you do this, your answer would be expected to be in standard form, like this. So if it was out of order, reorganize it so it's in the proper order. Largest degree to smallest. So that's all we have to do for adding polynomials. For subtracting polynomials, it's the same idea, except because we're subtracting, what it's like doing is adding a negative, or adding the opposite sign. So this would be a negative 2x to the 4th, this would be a negative 3x to the 3rd, a positive 6x squared, and a negative 5. All I'm doing is I'm changing this to an addition sign, and I'm changing the signs of every other term that comes inside the parentheses after it. So if we were going to subtract these polynomials, we would do the same exact thing we did when we added the polynomials. We want to look at degree, so 4th degree is going to be the largest term that we're going to be adding or subtracting. So 5x to the 4th, are there any other 4th power? There are. Negative 2x to the 4th. So 5 plus negative 2 is 5 minus 2, which would get us 3x to the 4th. The next thing we want to do is we want to look for x to the 3rds. You'll notice there's no x to the 3rd here. We went from 5x to the 4th to 2x squared. And this was written in standard form. Hunt around for it. If it's not there, take a look at the other value, and you're just going to add it into the expression. So we have here a negative 3x to the 3rd. We have nothing to combine it with, so we'll just write it next. Negative 3x to the 3rd. Next, we're going to focus on x squared. We do have a 2x squared here, so we're going to combine that with our 6x squared there. 2 plus 6 is 8, so we're going to get 8x squared. And then we want to look for x to the 1st power. We have a negative 8x to the 1st power. There's no x to the 1st power here, so we're just going to stick with our negative 8x. And then our final step, we add our constants. We have a 9 plus a negative 5 is 4. And then that's what we're left with. 3x to the 4th plus negative 3x to the 3rd. So 3x to the 4th minus 3x to the 3rd plus 8x squared minus 8x plus 4. Because they all have different degrees, we cannot combine these any further. That's as simple as we can make it, even though it looks kind of complex. So that's one way we can add. I personally like to add vertically. And the reason is you can line up your terms right away. It makes it a lot easier. So let me show you these same exact problems. We should get the same exact answer, but I'm going to do them vertically. So let's look at this top one. We should expect to get 8x to the third minus 6x squared plus x plus 13, because that's what we got last time. So I'm going to erase this. I wrote our answer down below so we can check it when we're done. Here's what I'm going to do. I'm just going to write our second expression right underneath the first one, and I'm going to do it in a way that I line up the terms. Think of it like place value, where you want to line up the place value, so the ones are with the ones, the tens are with the tens, hundreds are with the hundreds. We're going to do the same thing, but with the constants are with the constants, x to the first is with x to the first, x to the second is with x to the second, x to the third is with x to the third, and so on. So that's what we're going to do. This is going to line up nicely. I won't need to play around with it at all right, like I will with the next one. So let's take a look. We have a 2x to the third. We'll put that right underneath. We know we're adding these expressions. Negative 10x squared, we're going to write that down here. 8x and 10. So all I'm going to do is just add them vertically. And all you really need to do, you can ignore the exponent and just focus on the coefficient, the number in front. 6 plus 2 is 8, so it's 8x to the third. 4 plus negative 10 is negative 6, so it's negative 6x squared. Negative 7 plus 8 is 1, so it's 1x, a positive 1x, which might just be written as a positive x. And then 3 plus 10 is 13. So my final answer here should be 8x to the third minus 6x squared plus x plus 13, which is exactly what we got before. And it'll line things up for you so you won't make a mistake and miss a term. Sometimes if you're looking one side to the other, you might confuse which terms you've used and which terms you haven't. So this will keep you in line with what you're supposed to do. So let's try the second one. Again, I'm going to write the answer down below. 3x to the fourth minus 3x to the third plus 8x squared minus 8x plus 4. I'm going to erase the values I have. And you could change the sign right away and just understand that we're really going to be adding the opposite value that we had. The only other thing you're going to want to do here, you'll notice there's no x to the third here, so we want to leave a space for that. So I'm going to move 5x to the fourth a little further out. And then I'm going to write plus 0 x to the third. Or, if you want, you can just leave that blank, like so. And just understand that we don't have anything holding its place in place value, so we're going to have to add that blank area there. So there's our first expression. We'll write the second expression underneath, keeping in mind what is the degree, and that's going to let us know where we're going to line them up. So again, we're going to add these together because we changed the signs already, so we're adding negatives now. We're adding the opposite sign that we had. So we have a negative 2x to the fourth. I'm going to write that in over here. Negative 2x to the fourth. Negative 3x to the third. Positive 6x squared. We don't have anything to the x to the first power, so we'll move on, and our constant is negative 5. And so that's what we have, and you'll notice we have these blanks for x to the third for our first expression because we didn't have anything there. And for our second expression, we didn't have anything for x to the first. So again, we leave it blank because there's nothing there to add or subtract. So now all we have to do is just combine our coefficients. 5 plus negative 2 is 3. We get 3x to the fourth. Again, you want to leave those alone, the x to the fourths, because we are really just talking about quantity. If I had 5x to the fourths here, and then I took 2 of them away, how many x to the fourths do I have? I have 3 of them. So think about it that way. It'll be a little easier. You won't get confused with what to do with the exponents. You should have the same exponential values that you started with. All right, so negative 3x to the third, there was nothing to combine it with, so we just bring it down. 2 plus 6 is 8, so we get 8x squared. Negative 8x stays negative 8x, there's nothing to combine it with. And then 9 plus negative 5 is going to be 4. So again, when we're done, and I'll clear these lines out, we should have 3x to the fourth minus 3x to the third plus 8x squared minus 8x plus 4. So we're going to get the same exact thing that we started with last time. So hopefully that makes some sense. That's adding and subtracting. So you're going to make a quick camera adjustment. And then we're going to focus on the distributive property and multiplying polynomials. So the distributive property should be good practice for you guys. Hopefully you remember exactly what to do. When we distribute, we just want to multiply what's on the outside of the parentheses by each term on the inside of the parentheses. So this 3 would multiply the 2x, and it would multiply the 5. So if we were to do that, 3 times 2x is going to get us 6x. And then 3 times 5 is going to give us 15. So we would get 6x plus 15 as our answer there if we were distributing. Same thing here. We have 4x squared, and we're going to be distributing that to 3x and then to 7. The difference here is we're distributing with a variable, which we haven't had that much practice with. It's the same idea as how we would multiply exponents, though, so we want to keep that in mind. 4x squared times 3x, we do 4 times 3 is 12. And then x squared times x would be x to the third. All we have to do, add the exponent, just like we did in the previous unit. Over here, 4x squared times 7 would just be 28x squared. And then that's our answer, 12x to the third plus 28x squared. And that's all we have to do to distribute. When talking about multiplying polynomials, what you're going to notice is that it's just the distributive property. You're just going to have to do it multiple times, that's all. So, for instance, in this problem, you might hear the term, if you have anybody who's in another algebra class, you might hear the term FOIL. It stands for first, you multiply the first terms together. Then outer, you multiply the outer terms together. Then inner, you multiply the inner terms together. Then last, you multiply the last terms together. So if you hear somebody say, well, just FOIL it, they mean the same thing as distributing. The reason I'm calling it distributing is because it's one rule to remember, where FOIL only works when you have 2 binomials. So we have 2 terms here, we have 2 terms there. When you're multiplying a binomial by a binomial, you can FOIL. Anything else you have to distribute. So you might as well just learn one rule. So all we have to do here is distribute. So what I'm going to do is I'm going to multiply the 3x, that first term, I'm going to multiply by both terms inside the other set of parentheses. So we're going to do 3x times 4x, and then 3x times negative 7. If we do that, we get 3x times 4x is 12, x times x is x squared, and then 3x times negative 7 is negative 21x. So far, so good. Now what I'm going to do is I'm going to go to the second term in the parentheses, the positive 2, and I'm going to multiply both terms by that. When I do that, and I'm going to write it right underneath, we're going to get 2 times 4x is going to be 8x. And you're going to get 2 times negative 7 is going to be negative 14. So you'll notice the way I wrote it, you'll see some people write it all in one expression and then combine like terms, because that's all we really need to do. But what you'll notice is I wrote it the same way that we'll add polynomials, because that's what we're going to do. We're just going to add these when we're done. So all the x squareds I have are there, so it's 12x squared. I have a negative 21x and a positive 8x I have to combine together. When I do that, I'm going to get a negative 13x, because negative 21 plus 8 is negative 13. And then I'm going to have a negative 14 over here. And then that's my answer. 12x squared minus 13x minus 14. And that's all you have to do. Here's another example. This time we're going to distribute. We're going to distribute 2 terms, but we're going to have trinomials on the other side when we multiply. So what we're going to do here, again with the 2x, we're going to multiply that to each of the 3 terms. 2x times 3x squared, 2 times 3 is 6, x times x squared is x to the third. So we get 6x to the third. 2x times 4x is 8x squared. So again, 2 times 4 is 8. X times x is x squared. 2x times negative 10 is negative 20x. Then what I'm going to do is I'm going to line up with my next expression when I multiply by negative 6. So we're going to take negative 6 and multiply by 3x squared. When I do that, I'm going to get negative 18x squared. You'll notice I'm lining everything up. So this started with an x squared, so I'm going to write it where the x squared was for the previous distribution that we just did. Next, we do negative 6 times 4x. Negative 6 times 4 is negative 24, and it's just x, so we have negative 24x. And then our final multiplication, negative 6 times negative 10 is positive 60. So that's what we're going to be left with. We're going to have positive 60. So now what we're going to do is we're just going to line up all of our terms based on degree, and then we're just going to add them. So we're going to have 6x to the third stay 6x to the third. 8x squared plus negative 18x squared is negative 10x squared. Negative 20 plus negative 24 is negative 44, and that's x. And then we have plus 60. And then that's it. That's our answer. So we get 6x to the third minus 10x squared minus 44x plus 60. And that's how we're going to multiply these polynomials. Really what you're doing is you're multiplying and then combining like terms, so you're going to be adding as well. Final example I'll give you, well, next to last example. There's one more special case I want to show you afterwards, but this is probably the largest type of problem you'll have to see. It's really not that bad, it's more of the same, but it takes a little longer, that's all. So again, we have one term, we have two terms, we have three terms. We're going to distribute by all of them. So our first term, 7x squared, we distribute. When we do that, 7 times 2 is 14. X squared times x squared is x to the fourth. Next, 7x squared times negative 8x. 7 times negative 8 is 56, negative 56. And then x squared times x is x to the third. We then do 7x squared times 6. 7 times 6 is 42. And then x squared is just x squared. So that's what we get when we distribute our first term. Now we're going to distribute our second term. 5x squared multiplied by all three terms. When we do that, 5x squared times 2x squared. And I know it's hard to see, but this was a positive 5x at one point. So 5x squared times 2x squared. Again, we're going to line these things up. So I just want to make space. So 5 times 2 is going to be 10. Oh, I'm sorry. I meant to write this as just x. Let's do that. 5x times 2x squared is going to be 10x to the third, because x times x squared is to the third. So we're going to get 10x to the third. We'll write that in over here. 5x times negative 8x is going to be negative 40x squared. And then 5x times 6 is going to be 30x. So that's what we get when we distribute our second term. Our third and final term is 3. We're going to multiply everything by 3. 3 times 2x squared is 6x squared. Here's the x squared column. We write that in. 3 times negative 8x is negative 24x. And then 3 times 6 is 18. And so when we're done, this is what we're going to have. Now all we have to do is just add them together. So if you were doing this and you were just writing it out horizontally, you'd have 9 terms and you'd have to combine them all together. If you write them out based on the degree like this, it's a lot easier to keep it organized. So even if it looks like it's more work, I promise you it's not, because it's easier work. So the first thing we're going to do, 14x to the fourth. Then we're going to have negative 56 plus 10 is negative 46, so we're going to have negative 46x to the third. Then we're going to have 42 minus 40 is 2, plus 6 is 8, so we're going to have plus 8x squared. Then 30 minus 24 is going to be plus 6x, and then plus 18. And that right there is going to be our answer. 14x to the fourth minus 46x to the third plus 8x squared plus 6x plus 18. That's really it. There's just one more type of problem I want to show you, and the reason is it looks different, but it's really the exact same thing as what we've done previously. Here's the example. If I gave you 2x plus 1 squared, if I square anything, what am I doing? I'm multiplying by itself. So if I had 3 squared, it would be 3 times 3. If I had 5 squared, it would be 5 times 5. If I have 2x plus 1 squared, it's going to be 2x plus 1 times 2x plus 1. And I'm actually going to change this around. I'm going to make it 2x plus 5 just so you can see what's going on. A lot of people want to distribute the exponent here. If you did that, you're going to get a different answer than what you'd actually get if you do it correctly. So what you want to do is you just want to rewrite it 2x plus 5 times itself, which is 2x plus 5. And then all we do is distribute and combine like terms. 2x times 2x is 4x squared. 2x times 5 is 10x. Then we take the 5. 5 times 2x is 10x. 5 times 5 is 25. Our final answer here is going to be 4x squared plus 20x plus 25. And that's going to be our answer. You would not get that if you just distributed. So make sure, if you see anything like this, if you have a polynomial, it could be a binomial, it could be larger, but if you have a polynomial in there and you need to square it, you want to just write it out next to itself and then distribute like you know how. And that's all there is to it. Outside of factoring, that's everything we're going to need to learn for the rest of the year. So practice this. If you have any trouble, if you're unsure about how to do something, watch the video again. And I should be around at some point for extra help. So check in. If I haven't come around to talk to you guys, I will soon. If I have come around and you just don't know, ask around. Somebody's bound to know. But that's all you really need to know. So the next time you see me, we'll be live and in person. Until then, I'll see you later.